Hello everyone, today we'll be discussing cross-site scripting, different types and recommendations. So let's start. Introduction. What is cross-site scripting? XSS is a type of injection attack in which an attacker injects malicious script into the code of a trusted application or website. Here we can see an example of legitimate usage of login page where we add our name and we can basically submit and receive hello Lara. So what the hacker can do, use the same login page but add a payload, as for example this payload, and cause the application to act in a different way, and basically it can say hey, and here we can see the XSS Windows alert as basically this script should show an alert box like here with the string XSS. Alright, let's continue. So the attacker can also try to inject any code within comments. So everywhere we can, basically the attacker can add any data input. Key concepts of cross-site scripting. So the cross-site scripting is web-based attack performed on vulnerable web applications. So we know it's a web-based attack. Also, the cross-site scripting attacks, the victim is the user and not the application. That's what we need to know. The victim is the user, it's not the application. So the victim will be the person who is actually using the website. So this is also called client-side code injection. Also, the cross-site scripting attacks, malicious content is delivered to users using usually JavaScript. Okay, they're using JavaScript. We'll be discussing this in our next slide. But first, what is a client-side code? Because we've mentioned here client-side code injection. So, it is JavaScript code that runs on a user's machine. In terms of websites, client-side code is typically code that is executed by the web browser after the browser loads a web page. So that's why it's called client-side code. An example of client-side code is JavaScript. Okay, why XSS injection happens? First, this attack succeeds if the web application doesn't employ enough validation or encoding, similar to SQL injection or XML external entity vulnerability. Basically, the web application should employ enough validation and encoding. How cross-site scripting injection happens? An attacker must first find vulnerable user inputs within the web page or the web application. So if there's not any vulnerable input, in this case, the attack will be unsuccessful. The attack also should create input content, often called a malicious payload, script, or code. It's in our case. So yes, the attacker should basically craft their payload and inject it into the a vulnerable web application. Type of XSS payloads or the client-side programming languages. Okay, so as we said, this is a client-side vulnerability as it's using the client-side programming languages. In this case, it's JavaScript is probably the most common one. We have the HTML, we have VBA scripts. These are just an examples. Here how the JavaScript looks like. We can see the elements. This is the alert hello world, and this is how the user should see basically the JavaScript. Okay, the HTML, this is how the HTML looks like. and this is how we can basically see it from a website. When we are browsing, you can see here in bold gray day. So the HTML use predefined tags like here, and so it has specific tags, for example, in contrast with the XML language. All right, VBA script. That's how the VBA script looks like. And hello world. There can be different types of also XSS payload with different client-side programming languages as Flash, ActiveX, CSS, and etc. But these are the probably most common ones. Okay, let's move to the next one. Cross-site scripting classification. All right, let's see the different types, or probably the most common ones that we can actually see. So the classification, the first one is reflective, non-persistent cross-site scripting. The second one is stored or persistent cross-site scripting, and the third one that we'll be discussing is DOM-based or client-side cross-site scripting. And now we will start explaining all of them. The reflected or non-persistent cross-site scripting. So these attacks occur when a malicious script is reflected off a web application to the victim's browser. Let's see how this works. We have the attacker. The attacker discovers a vulnerable website that enables script injection. Okay, let's say, pretend that this website is called tombRaiderforum.com. The attacker injects the website with a malicious script that steals visitor session cookies. Okay, this is the payload that the attacker would add to the website. So Tomb Raider forum news, this is script, and the source. So this is the attacker website called bad site, and this is the payload that is hosted within the this website. So if the attack is successful, basically the the attacker would manage to steal the user's session cookies, because that's the payload for. Okay, and now every time a user clicks on the link, the malicious script is activated. Okay, and when the malicious script is activated, visitor session cookie is sent to the hacker. That's how it happens. Okay, so attack conditions. The attacker should locate a vulnerability in a web application. Let's pretend that this web application is vulnerable, lack of validation or encoding or whatever is the case here. This website, Tomb Raider forum, is vulnerable. The attacker should inject malicious scripts into its server, for example, via comment field, visitor walk or message forum, or etc. And then the attacker must deliver the payload to the victim. So we have it can be via phishing or any other type of social engineering, but the attacker should deliver the payload. Okay. Just to mention here, sorry, before we go to the next page. So the reflective one means that the only way that this script is being executed is when the user, clicks on the link. So if the user doesn't click on the link, this attack, the payload won't be executed. Okay, that's why it's reflective. It's non-persistent. It's not stored within the website. The website is vulnerable, as we've mentioned. There should be a vulnerability on the web application, but once the attacker basically grab the payload and send it via phishing or social engineering way, the user, the victim, should click on the payload, so or the link, in order to basically activate this payload. Okay, all right, and this slide is in regards to stored or persistent cross-site scripting. Let's see how this works. These attacks are those where the injected script is permanently stored on the target servers. And on purpose, I'll be giving you the same examples from the reflected one. So the hacker discovered vulnerable website that enables a script injection. Same site, Tomb Raider forum. The attacker injects the website with a malicious script that steals visitor session cookies. This is the same payload. You can see so the stealcookie.js JavaScript payload is hosted on the hacker server. And now, every time the site is visited, the malicious script is activated. So, just in comparison with the previous one, where every time when the link from the phishing email or from whatever the link is clicked by the user, this payload will be activated. In this case, is every time when a visitor visit the website. So a user visit the website, the visitor session cookie is sent to the hacker. So it's very important to mention here, it's not necessary when someone accesses the website to click on the payload, basically on the link, to execute it. No matter if it clicked or no, once the user access the website, this payload will be executed because this payload is embedded within its store permanently on the target server. Okay. Attack conditions, pretty much the same. The attacker should locate a vulnerable web application. The attacker should inject malicious script into its server, so via comment field, visitor log, or message form, or etc. But the attacker is not necessary to send any phishing email or using any of the social engineering methods, as the payload will be stored on the server. Let's see both examples, two examples, one for the reflective one and one of the stored cross-site scripting within the next video. Thank you. Hello, okay, now I'll be showing the reflected cross-site scripting. We are here with the Web Security Academy lab. So as you can see here, I've run a few searches, but basically you can write whatever you want. Hi, hello. Okay, zero results for hello. Anyway, you can see here I already searched for this. Now I'll try to insert within the search section this script that should show the alert of 1, and that's what we can see here. We can see the alert 1, and okay. So congratulations, you solved the lab. So as you can notice here, once I click on search and the alert, basically the payload is being executed straight away. Straight away the payload is being executed. And now you will see the difference when I try to run the same payload but with the stored cross-site scripting. Hello again. Now we are here with the stored cross-site scripting. It's again Web Security Academy lab. We'll be using the same payload. So let's just view one of this. Okay, we can have here a section where we can leave a comment. So that's what we'll be checking for cross-site scripting, somewhere that we can input a comment. All right, I will just input, let's say, Haya, name, Lara, email, Lara Croft at gmail.com, website tombradar.com, post, please match the format. Probably double, oops. Let's see if this will work. Okay. HTTP. Okay, it looks like this works. Okay, your comment has been submitted. Let's go back and see. Oh yeah, that's me. Hiya. All right, let's try a different thing. What? Which one? Hello. Okay. Okay, great. What we can see here, hello, it's a big hello here. That's because I use the predefined HTML tags for header, and the web application interpreted as HTML tags. It means that the web application is very likely vulnerable. So I will add just this comment here, script alert 1, where I want alert box with the number 1. And let's see if this would work. Post a comment. Okay, oh, congratulations, you saw that fill up. Let's see how. Because I can't see any alert box at the moment, but when I go back to the log, I can see the alert. This means that the web application is vulnerable to stored cross-site scripting, and in comparison with the previous reflected one that we saw, where once we clicked on the search on OK, we instantly received this alert box. But here we went back to the comment. So this means that every person, every user who access the comment section who access this particular page will has this box in front of them, meaning that the website is vulnerable. And that's the difference between the reflective one and the persistent one. This one is basically stored on the web server. That's why it's called stored. All right, and next move to the last category and type of cross-site scripting, DOM-based or client-side cross-site scripting. So first, we want to know what is DOM. DOM stands for Document Object Model. It's a model that browser use to render web pages via JavaScript. So that's why we use it. It's a programming interface or API for web documents as HTML and XML. This is how it looks like. That's the DOM. Okay? And the DOM represents the page in a logical tree so that programs can read, access, and change the document structure, style, and content. That's how it looks like. This is the HTML DOM tree of page elements and attributes. As you can see, document, here the root element, HTML, here we have the head, title, my title, attribute, element, text. This is the body basically. So this is the logical tree. And this is an example for XML parser. I will explain this in the next slide, as you have to know what basically is happening here and what inner HTML means and how basically the DOM parser works here. So I'll be explaining this, but basically the DOM can be accessed, right-click and inspect elements from the website, and you should be able to see the DOM. Alright, yes, we'll pay attention to this here, but let's see the next slide. Okay, that's the output. Here we can see title, hello people, and get element by tag name, title. So get the element from the title, hello people, hello people. But you will see in the next slide why I actually show you this now. All right, so before going to DOM cross-site scripting, we have first need to explain very important DOM functions. The DOM has two important functions. The first one is called source, and the second one sink. The source function is any JavaScript property or function that accepts user input from somewhere on the page, takes data from an attacker controllable source, for example, a URL. That's the source. As it's self-explanatory, source, we're sourcing from somewhere. These are the examples. So these are some source function here. Document URL, you can see again, it's related to source, some URL, location, document cookie, document referrer. Here the sink. It's a function responsible for the untrusted input to get outputted on the page screen or executed by JavaScript within the page. So the sink basically, its responsibility is displaying something on the page on the screen so we can see it. And these are some sync function element inner HTML that we actually saw in the previous slide, eval, auto HTML, document write. All right, and this is one example for the DOM document where we can see a fraction of the document, my web page, hello world, click, and we can see this function document get element. So this method returns basically a live HTML collection of elements with the given tag name. Okay. What else we can see here? Inner HTML. So the inner HTML property is basically used to change the content of the HTML page to whatever is given to it. So the content of the HTML page. In this case, let's see what I mean by this. So there is hello world here within the tags H1, but the output will be hi people, not hello world, because that's the inner HTML sync function from here, and that's why we can see hi people. Okay, and now let's see what is actually DOM-based cross-site scripting by knowing the important functions of the DOM and the source and the sink. So we have the attacker. The attacker injects a payload. This is the payload. Okay, alert to show the box, the alert box 1. It injects the payload is injected using the source function, this one, Windows location search, that will be stored to the DOM. So the attacker injects a malicious payload using this function, and the payload will be stored to the DOM. Okay, the payload then is executed when the data is read from the DOM and displayed to the web browser using the sync function. So let's repeat. The attacker is injecting the payload. This is the payload. It injects the payload basically using this function, and it will store the payload to the DOM. And then the payload will be executed, it will be read from the DOM and displayed to the web browser with the help of the document.write sync. And that's how this will be seen here. Okay. In this case, the DOM-based cross-site scripting happens when the web application's client-side script writes user-provided data, so source function, to the DOM. The web application reads the data from the DOM and delivers the results back to the page or the thing as for us to see it. Also, something to note, the DOM-based cross-site scripting attacks can only be seen by checking the document object model and client-side scripts at runtime. All right. Normally, cross-site scripting vulnerabilities allow an attacker to masquerade as a victim user and to carry out any action that the user can perform and to access any of the user's data. So let's now, before seeing the prevention and mitigation, let's now see how actually the DOM-based cross-site scripting works. Hello, so this is the DOM cross-site scripting lab in document.write sync using source location.search inside the select element. I'm gonna pick one image here. It's gonna be this one. Okay, and this is the only drop-down menu and the only place where we can input something. Now is the inspect, where we can see basically the DOM and quickly type and search for London because I want to see how actually from where the data has been retrieved. So we can see here variables London, Paris, Milan, var storable new URL search params window location search. This is the function. This function is basically used to retrieve all the data after the question mark here from the URL. So the product ID. What else we can see? Get store ID. We don't know where is this get store ID, but after that we can see the document.write function being used to display the data from the DOM. So what we would try here is to add the store ID and store ID equal 123 ABC or ABV is fine as well. Okay, let's see if something will change. Yeah, we actually added a new item here. Let's see. Okay, 123 ABV. Search 123 ABV. There we go. Okay, we've added a new option here, meaning that it's vulnerable and aside to DOM cross-site scripting. So what we can try in this case, instead of this, we can try a different payload. So here we'll add a payload for alert 1 and just type enter. And done. So we can see that instead of adding a new option, we can add this and the alert will show with the OK, meaning the website is vulnerable to DOM cross-site scripting. Alright, and now a prevention and mitigation. And we start with use secure coding practices. The next one is implement web application firewall. The web application firewalls have different methods to counter-attack vectors. In this case, for cross-site scripting, most will rely on signature-based filtering to identify and block malicious requests. We have never trust user input, so always perform input validation and sanitization. So validating the input to make sure that it only contains an expected set of characters. The next one is implement output encoding. So here again, you have to pay attention to symbols that are used for cross-site scripting. The next one is perform penetration testing to confirm remediation was successful. Of course, here we're talking about big companies. Ensure that web application development aligns with OWASP cross-site scripting prevention cheat sheet. I'll leave this cheat sheet in the description below. And now we have additional recommendations for the reflected cross-site scripting. So from user's point of view, vigilance is the best way to avoid cross-site scripting. Avoid clicking on suspicious links found in emails from unknown senders, a website comment section, or social media feed of unknown users. All right. Thank you so much, guys. I hope you really liked the video. If you have any questions, please let me know in the comments. Please subscribe, share, like, and comment. See you.